Okay, here we go. Alright, so I had previously given you guys some YouTube videos to watch on the sub. I think gave it to you guys. But I'm just going to reteach it from the scratch, okay? Our graphs we're talking about are y is equal to sine x. Yeah, the notes will be available on Schoology. I'm not sure if I can PDF my notes. But the YouTube video should still be up. Okay, so the idea is we're graphing sine and cosine, and the graphs are very similar. Not the same, but very similar. And the basic pattern for these, if you remember from graphing lines, we said y is equal to mx plus b. And when we said this, it was easy for us to graph lines because the m stood for the slope and the b stood for the y-intercept. So this gave us guidelines to graph a graph really quickly. For instance, if I say y is equal to 3 over 2x plus 1, we could graph this graph in literally seconds when the y-intercept was 1 and the slope m was equal to 3 over 2. So we graph the dot at 1, we count 1, 2, 3, and we run 2. And that was really easy to graph. So we also did the same thing for parabolas. If you remember, if we said y is from algebra 2, we said y is equal to, let's say, x squared plus 6x plus 8. And you could graph these using an x and y table and just plug in values. But you learn a method called completing the square. When you complete the square, you could write this in what we call vertex form. And if you write it in the vertex form, the vertex was automatically given, and we were able to graph that really quick. Where the vertex is now negative 1, 2, 3, negative 1. Then the parabola comes out with the a value of 1. And we had a pattern for that. So now sine and cosine kind of follow this trend. Same thing for your other, remember there are total 6 trig identities, 6 trig functions: sine, cosine, tangent, secant, cosecant, and cotangent. And the goal of this section is to actually graph all 6. So you guys might remember SOHCAHTOA, right? SOHCAHTOA is right? SOHCAHTOA. And that had to do with sine, cosine, tangent. And then when you did the reciprocal, we dealt with the other ones, with the secant, cosine, cotangent. So I'm graphing sine, our basic standard equation. Here's a full one, but we're not going to do the full one today. We're going to do part of it. Is equal to a sine bx minus c plus d. And just like over here when it came to y equals mx plus b, the m and the b told us the characteristics of the graph. Over here, vertex form. This vertex form was y is equal to a x minus h squared plus k. H and the k were the vertex of the graph, and the a was how fast the graph changed. Our sine and cosine graphs follow the same idea where there's characteristics, and if we can figure out what those characteristics are, if we can figure out what the characteristics are, we can graph these actually really quickly. Oops. Darn it. Sorry about that. This is going to be cosine of saying bx minus c plus d. See? So sine, cosine, tangent, secant, cosecant will all have these same characteristics of A, B, C, D. Is this for period 2 as well? No. Period 2, this is for really just Ms. Yagi's class, because we covered Mr. Ko's class, my class covered this in first semester. Okay, so let's start off with two things that are pretty easy to graph, the A and the D value. So A, we're going to say stands for amplitude, and D is going to be a vertical shift. Amplitude and D is a vertical shift. And a vertical shift means I'm going to be able to move the graph up and down, and amplitude is how tall the graph is, you could say. And these are the two of the easiest things for us to graph. Now, let's go off and start off actually with looking at the pattern of a sine graph. Sorry. So if we say sine y is equal to sine of x, if you guys could get a scientific calculator out, the numbers I'm going to plug in, I want you guys to try it real quick. Make sure your calculator is in what they call radian mode. So we're going to create an x and a y graph. So x and a y, x and a y. And we're going to plug in a couple of values here. We're going to plug in 0, pi over 2, pi, 3 pi over 2, and 2 pi. So you're plugging in, oops, too much stuff on my desktop. So be sine of 0 on your calculator, then sine of pi over 2 on your calculator, then sine of pi on your calculator, and sine of pi over 3 pi, darn it, 3 pi over 2 3 pi, this pen isn't always working, 3 pi over 2 on your calculator is equal to, and then sine of 2 pi on your calculator. We'll end up with the sine of 0, you should have got 0. The sine of pi over 2, you should have got 1. The sine of pi, you should have got 2 pi. No, sorry, not what I'm talking about. You should have got back 0. Erase that. Got 0. At sine of 3 pi over 2, you should have got negative 1. Sine of 2 pi, you should have got 0. So if we try graphing this, the highest value we're going to have is 1. The lowest value we're going to have is negative 1. And if we break this at the end of 2 pi in the x direction, half is pi. Half of that is pi over 2. And then half between pi and 3 pi over, between pi and 2 pi is 3 pi over 2. Okay, so we plug in our, if x is 0, the y value is 0. If x is pi over 2, the y value is pi over 2. If x is pi, the y value is 0. If x is 3 pi over 2, our y value is negative 1. And the sine of 2 pi is back to 0. Now how could I get, so if I just draw random lines, this is not the graph that we want. So it's going to be a little more smoother than that. So you want to have it like a little more smooth. It really looks like two hills. And that's what our sine graph is. But our goal isn't to graph all these points every single time we want to graph a sine graph. So this is how we're going to do it. We're going to look at the characteristics of this graph. And I'll give you an example. Y is equal to 3x, 3 sine of x. Okay? And so we change the a value, and we call the a value my amplitude, right? My amplitude. So what could you predict if I multiply a number by 3? A number by 3. It's 3 times as large, right? So the idea is we're taking our numbers, our y values here, 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 and here, and multiplying them all by 3. Times 3, times 3, times 3, times 3, times 3. That seems like a not that bad of a deal. But here's our fast way of doing it. If you look at the numbers that we graph, 0, 1, 0, negative 1, and 0 by 3, those numbers are actually still going to be pretty easy. It's going to be 0, 3, 0, negative 1, and 0. So what happens is our a value changes. So we're going to go ahead and draw this again. And our a value is 3. So we're going to count 1, 2, 3, negative 1, 2, 3. I'm going to draw little dotted lines here. Change colors if I can. At 3 and negative 3. And our period hasn't changed. This is still 2 pi. This is still pi. These are our tick marks. Remember we have 4 tick marks here. So it's still going to be 0. 1 times 3 is 3. 3 times 0 is 0. 3 times negative 1 is negative 3. And 3 times 0 is 0. And this graph keeps on going in both directions. I mean, it's kind of like very similar to our last graph, except since we multiplied everything by 3, it became a lot taller. So that's 3, that's negative 3. Right? But what if this was 4? If this was 4, this number here would just become 4. If our a value was 5, this number here would just become 5. And that's what a value. A value is one of our easiest changes that we can do to our graph, and that's what we call the amplitude. It's our multiplier. Okay, so let's talk about our, so this was our A. Let's go into the B. No, not this one, D. D, our vertical shift. Okay, vertical shift. So if I say y is equal to sine of x plus 3. Remember, this goes a sine of x plus d. Now we haven't had to deal with b and c yet, but know what? B is actually in here already. If I wrote this as a sine of bx plus d, our b value, b would equal to 1. And the b value is going to be our, it helps us find our period. No, but b isn't the period, it helps us find our period. Because b gets plugged into the equation 2 pi over b. Okay, so that's kind of weird. So if b in this case was 1, if b was 1, so a is equal to 1, b is equal to 1, and c is equal to 3, we know the characteristics that my amplitude is 1, my vertical shift is, sorry, this is a d. I'm sorry, that's a d. D is going to be plus 3, and my b is 1, which means my period is 2 pi over 1, which is 2 pi. This means that my graph will start and stop, sorry, not will stop at 2 pi. It takes 2 pi to finish one full rotation. If you remember what 2 pi is, 2 pi is one full circle. And we'll demonstrate that in just a little bit. So let's go ahead and graph these 3 characteristics on our graph. Now, the way I graph things, I always go this way. You go from D and you head toward A. The period is how long it takes me to finish one full graph. Because this graph will continue in one more cycle, and then one more cycle, and this goes on infinitely. So how long does it take you to finish one full cycle? The example at Hamilton is that a period is like, what, 78 minutes? That's how long it takes us to finish one full class. So to start and stop one sine graph, it takes me 2 pi to finish one full graph. So in this case, it takes us 2 pi to finish this one full graph. Okay, so we just draw our graph, and we'll start graphing from D, B, then A. The D we said was my vertical shift. So imagine looking back up here, isn't this just a regular sine graph? And we added plus 3 spaces to it. And we said we know our values for our sine graph. It's 0, 1, 0, -1, 0. So everything is being shifted up 3 spaces. Now here's the easiest way to draw it. Since we started off at 0 originally, right? We started off originally at 0. That was the center of my graph. If I added 3 spaces up to each of these points, plus 3, the graph should be way up here now. It should be higher. Well, we're going to do that. And we'll make our life a little easier by just drawing our new axis. So instead of graphing it at 0, we're going to graph, we're going to graph it at 3. So we're actually going to count 1, 2, 3, and then I draw a new middle ground. And that's going to tell me, hey, my sine graph is going to rotate now around this graph here. But is it long? Is it short? Is it tall? Is it short? And so we're going to use our ABCD to draw the characteristics of the graph. Very similar to how we use y equals mx plus b to give us the points on the graph for a line. Okay, so we graph D was 3 spaces up. C is 3 spaces up. And now we're going to go ahead and deal with B. We said the graph takes 2 pi to finish. So we just go ahead and say, you know what, we start at 0 here. And if we start 0, we're going to go all the way to 2 pi to stop. Now to help you with this graph, I only require 4 real points. Well, 5 if you include endpoints. But we're always going to take a graph, I'll draw it over here. We're always going to take a graph since we have the beginning and the end. We're always going to cut in half, half, and half. That's how we'll graph all our graphs. Half, half, and half. Half, half, and half. And that will space our graphs really nicely. Sometimes kids will graph it, and if they don't space it nicely, one side's way bigger than the other. Or maybe this side's bigger and it's super long over there. But it has to be nicely balanced right in the middle. And we go up, down, down. So we'll do that right now. So we're going to draw half, half, and half. And you can label this as we first practice. We say this is pi, pi over 2, and half of a half, 3 pi over 2. You can think of this as money. This is $2. This is $2. Half of $2 is $1. Half of $1 is 50 cents. And what's the halfway between $1 and $2? $1.50. Okay, so we graphed, we're now going to copy those tick marks onto my new middle ground. Remember, we had shifted our axis all the way up 3 spaces. So I'm going to go ahead and copy these 3 spaces. Okay, so we finished with D, we finished with B. Now let's do it. A is amplitude. From our new middle ground, 3, we're going to add 1 going up, subtract 1 going down. And I use that with a little blue here. I'm going to draw my little tick marks. And this is as high as my graph can go. And this is as low as my graph can go. So this is my highest point. My lowest. Highest and lowest. Now, we could do the numbers we could say when x and y, when it's 0, pi over 2, and pi, we can plug in a sine of x plus 3, whoops, sine of 0 plus 3, we could do that. Sine of pi over 2 plus 3, sine of pi plus 3. But please don't do that. The idea of us drawing this framework here is because we're going to follow our waves here. So our first graph is going to be sine is always going to start right in the middle, and that's a trick. Sine will always start in the middle of the graph. And sine positive always goes up. It's going to go up. Up to my amplitude. Up to my amplitude. Up to my amplitude. Does this graph go up or down? And look, the pattern goes up, down, up, down, up, down, up, down. We're going to go up and then back down to 0. Look, this is the new middle. This is my new 0. We're going to go not up again. We're going to go down now, all the way down to my lowest value. And then back to my 0. And you can see the framework for the graph. We'll go up and down and down. And of course, this graph keeps on going. So let's look at the pattern over here. The sine graph goes up, down, back to the middle, down all the way down, and then back to 0. Up, down, down to the bottom. Up. And the idea of a sine graph, it's the y values. A sine graph, the y values of a circle. Specifically, we call it a unit circle. So if you look here, now so if this was a unit circle of 1, 1, -1, -1, this point here would be considered 1, 0. This here would be 0, 1. This one here would be -1, 0. This one here would be 0, -1. Now, the way we talk about degrees is that this is 0 degrees over here. 0 degrees always starts on the right. 0 degrees. This is going up 90 degrees. This is 180 degrees. This is 270 degrees. And in radians, this is 0 radians. This is pi over 2. This is pi. 3 pi over 2. And back to 2 pi. Now, here we go. If we start over here at 0, what's the y value? The y value is 0. Y value 0. And if I start moving up to pi over 2, So remember, we are turning in radians. We're turning pi over 2. What's the y value now? The y value is 1. As I head toward pi, as I'm turning, my y value is 0 now. And as I continue to keep turning, my y value is -1, and my y value is 0. And these are our y values up here. 0, 1, 0, -1, 0. These are our y values. So sine will always have this pattern. Okay, let's go back to application. So let's go back and give a quick example. What if I give you guys the problem? 2y is equal to 2 sine of x minus 1. What is my a value? What is my b value? And what is my d value? We still haven't had a c value. No parentheses, no c. No parentheses, no c. So my a value looks like it'd be the number 2, right? Do we have a b value? What's in front of the x? Remember, the pattern is always going to be y is equal to, thank you, my b value, it's going to be invisible. In front of the x, it's going to be invisible 1. And then my d value is -1. Okay, sorry. There's actually a 5-second lag between when I say something and when it appears on YouTube. I've been trying to deal with it all morning and I can't fix it. Oh well, we'll just deal with what we got. Okay. Okay. So we draw our graph here. Now, if you notice, I'm actually not doing any calculations. Only calculation we need to do is figure out my period is, and we'll figure that out in just a little bit. And we always graph from D to A, D to A, D to A, D to, I gotta stop that. We graph from D to A. So D is my vertical shift. And we know we're going to drop the graph by -1, so we're going to drop it by -1. So you're down here, -1. And I'll draw a dot, 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 dot. So trust me, it actually really helps. So now this is the new middle of my graph. New, I guess center, the middle of my graph now. We want to say we don't have a c value, so we have no, is what we're going to eventually call a horizontal shift. So you know the graph starts at 0. Our b value is 1. We said that refers to my period, so the equation is p is equal to 2 pi over b, which is 2 pi over 1, which is 2 pi. That means my graph starts as, because my c is 0, we start 0 and we're going to go all the way to 2 pi. Okay, so now that I know when the graph ends, I can divide this into half, half, and half. And this will make my graph nice and spacious. Half, half, and half. Again, it's so that my graph isn't heavily weighted on one side, right? A little tiny lump. That doesn't look right. You could label our values here. Half of 2 pi is half of 2 pi is pi. Half of that is pi over 2. And if you want, you can also look at it this way. Counting this tick mark here is pi over 2. This tick mark here is 2 pi over 2, which becomes pi. This tick mark here is 3 pi over 2 because I'm counting by pi over 2's. And this guy here is 4 pi over 2, which really is 2 pi. So I'm write 3 pi over 2. Okay. Now, we have the spacing now. We finished our D. We finished our B. B helps us find where we end, as well as it helps us find, oops. So now we have our A value graph, and we said A was amplitude 2. Now, remember, the amplitude is how high and how low the graph goes. So from our D value, we're going to move 2 spaces up. See, 2 spaces up. See, that would be 2 spaces. This would be 2 spaces up here. And then this would be 2 spaces down right here. Oops. So we're going to count 1, 2. So I'm going to draw my low dot. That means blue. And down 2, down 2. As you can see, the graph has actually grown taller. Up 2, down 2. It's a little bit wider than the last graph. Let's copy our tick marks over. And since this is a sine graph, the sine of 0 is still going to be 0. And since it's positive, we're going to go up, down, down, up, up, down, down, up. And this is our sine graph. Not only did we increase the amplitude, we also lengthened the graph because the period is now 2 pi. So how do these translate to cosine? Well, it turns out cosine starts off very similar to this, except let's go back to our unit circle over here. Okay, go to unit circle over here. Cosine is the x values. So if they're the x values, let me go ahead and just draw this out over here. 0, pi over 2, pi, 3 pi over 2, and 2 pi. What's the x value at 0 degrees? The x value is 1. What's the x value at pi over 2? X value is 0. What's the x value at pi? X value is -1. What's the x value at 3 pi over 2? It's 0. What's the x value at 2 pi? It's back to 1. Now, if we wrote the same equation, y is equal to 2. Let me write this different color so you can see. Let's use red. Y is equal to 2 cosine of x minus 1, a, b, and c, and d, sorry. These would all have the same characteristics as our sine graph up here, right? Same a, same b, same d. So d would still be here, b would still be at 2 pi, and a would still be this whole section right here, up and down 2. All the characteristics would be the same. So I'm just going to draw here. The graph would just look like this. Up, 0, down, 0, up. So my point for sine and cosine, the way we set up the A, B, C, and D will be the same regardless if it's sine or cosine. The only difference between sine and cosine is where we start. So using the skills that we worked on for sine graphs, we use those same exact skills for cosine graph. Except, notice, sine starts at 0, and cosine starts at 1. In this case, our amplitude. Okay, so if you can graph a sine graph, you can graph a cosine graph because it's the same exact skills. So let's go ahead and do one more just a made up graph. Y is equal to 1/2. Let's do a cosine graph. Cosine of x, let's say it's going to be plus 1. A is equal to 1/2. B is equal to 1. And we have no C, no parentheses. And D is equal to 1. Without taking a breath, we go ahead and start drawing D to A. My D value is plus 1, so we know I raise the graph up by 1. Okay, and then, sorry if you hear my kids screaming in the background. That's our D value. D is equal to 1, so we raise the graph by 1. And then my period is equation 2 pi over b. Always 2 pi over b for sine, cosine, and tangent. No, not tangent. Secant and cosecant. Sine, cosine, secant, so cosecant. No. 2 pi over 1. In this case, it's just 2 pi. So we know we're going to stop at 2 pi. How do I know this is 2 pi here? I don't. Just make a mark. This is your graph. Here we go, half, half, and half. We always draw the half, half, and half to make sure I do have a nice separation. I'm going to copy these tick marks up. 1, 2, 3, 4. You can label them if you want. We have a, we finished D, we finished B. Let's finish our A value. Now A value is going to be a little tough here. I'm going to zoom in a little bit. So remember, our A value is my amplitude. So from the center, we are going to move half up. If this is 2 here, and this is 1, this is 2 and this is 1, this is 2, this is 1, half up would lead us right in the middle here, right in the middle there. So this amplitude really made this a really skinny graph. Made this a skinny graph. So I should just draw right here. Half space up, half space down. Okay. We said this was cosine. Does cosine start at from 0 or 1? So here's the thing, the sine of 0 is 0, and the cosine of 0 is 1. So cosine always starts on top for us. So I want to graph, I would just put the dots. My next dot would be at 0. Next dot would be at the going down. And then back, up, 0, down, 0, up. And see, the amplitude here, this blue line keeps me on top, and the blue line bottom keeps me on bottom. Keeps me nice and level through the whole graph. Down. And of course this graph keeps on going. And if I keep on going, the graph could continue. Keep on going. Okay. Any questions about what we just did? I'm still trying to figure out if Miss Hurst is going to take over the class. What I thought I would help out with was just trying to help you guys figure out how to do sine cosine. This is really half the lesson for sine and cosine. There's still another section where I teach you guys how to manipulate the b values and d values. The b value is actually very easy to manipulate, but the d value, that's when it gets confusing. But if you can at least get A, B, and D, you're in really good shape. But I'm waiting for Mr. Goslin to tell me what's going on. I think Miss Hurst is supposed to take over the class, but I didn't want to leave you guys hanging, especially if I could give you guys a lesson here. There's still tangent, cotangent, secant, cosecant. Secant and cosecant are actually very easy, and tangent is just slightly tricky. Okay, if you guys have any questions, you guys can go ahead and email me through Schoology, and I'll probably have another lesson tomorrow, about 2 o'clock. Okay.